Welcome to today's FDTD Go 16 Applications webinar. Today we're glad to have Matt Maley from the National Weather Service, WFO, in Monterey, California join us. And he is going to be talking about the historic North Bay wildfires from October of this year. First, we'll lead off with some protocol. All of these are recorded and available on the visit web pages at the following URL. If you'd like to lead one of these in the future, just let either myself, Dan Bicus, or Scott Lindstrom know, and our emails are listed down there at the bottom. A few protocols to go over. Our speaker will have about 20 minutes, and you can either send the questions via the GoTo chat, or following his talk, we will have a Q&A period via the phone. We'll be done by 19:30 UTC. We'll definitely be under 30 minutes. Please remember, do not press hold, and also remember to mute your phone when you're not speaking. So, without further ado, I will turn it over to Matt.
Okay, can you see my screen?
Yes.
Okay. Well, thanks, Dan. Thanks for having me. As Dan said, my name is Matt Maley. I'm an incident meteorologist from the Monterey Forecast Office here in California, and I was the incident meteorologist deployed to the wildfires in the North Bay of California. Just to, as it says here on the first slide, kind of honing you in as to where these fires occurred in the state of California. Just north of San Francisco is what we refer to as the North Bay. The three fires that were my main responsibility were the Pocket Fire, the Tubbs Fire, which was the most devastating of the three, and last but not least was the Nuns Fire. So they say a picture is worth 1,000 words, and this picture pretty much says it all. I took this picture as I drove through a neighborhood called Coffey Park. Coffey Park is a smaller neighborhood on the north side of Santa Rosa, and I just saw complete devastation. I've been an incident meteorologist since 2007, and I've been on several wildfires. I've been on urban interface fires before, but I've never seen anything like this. Just seeing house after house, neighborhood after neighborhood of just complete devastation was mind-blowing. I was just shocked at what I actually saw. As it says here in the bullet points, unprecedented damage, partial to total loss. Now, these numbers are likely to change over the next few months, but the initial estimates, partial to total loss of almost 15,000 homes. This now ranks as the costliest urban wildfire in U.S. history at roughly $3.3 billion. The previous record went to the Oakland Hills Fire, which was a little over $2 billion. And last but not least, unfortunately, there were about 42 fatalities. A lot of that was just due to the extreme nature of this fire and the rapid rate of spread and how much fire actually occurred in such a short amount of time. People couldn't just get out of the way. That's why it led to a lot of the fatalities. Here's another photo from a different neighborhood. I also took this one. This is the Fountain Grove neighborhood, which is on the northeast side of Santa Rosa. Once again, the picture kind of saying everything. Complete devastation. This neighborhood was completely impacted by the fire as well, with a lot of the homes being lost. So here's a satellite view of that same neighborhood before and after. So on the left-hand side is the before, and on the after is complete devastation. Several homes you can see there. There are a few on the top left corner that did survive, and they are still standing, and people are back in those homes, but everywhere else in the neighborhood, just a total loss. So how does this rank in history? I mentioned it's the costliest urban fire, but now the Tubbs is ranked, and this isn't necessarily a list you want to be ranked on, but this list here shows the Tubbs fire is now ranked as number one when it comes to most destructive fires in California. Another fire, the Nuns, also is ranked at number 6. The Atlas fire wasn't a fire I was actually on, but that was a fire that was over near Napa that occurred at the same time. That one got ranked at number 10. And then a Redwood Valley fire, which county is ranked at number 16. So during this firestorm across the North Bay, 3 of the fires that I was actually part of did make the top 20. So there again, kind of showing you how extreme this event actually was. So kind of setting the stage here, we have some antecedent conditions. So what led up to, or what was the main driving force for this, quote, firestorm to actually occur? Well, we had 5 years of record-breaking drought across California. So not just across the North Bay, but much of the state saw lots of stressed trees from both morbidity and mortality. Some of that was drought, some of that was disease. So that kind of helped set the stage from a fuel standpoint. Then last winter, this might be a little bit counterintuitive, but we actually had a really, really wet winter here across most of California for 2016, 2017. So that allowed for a lot of regrowth and a lot of rapid growth of the finer fuels. And from a fire standpoint, it's the finer fuels that tend to carry the fire into the larger fuels that would be your trees. And then 1 week prior to this event, we did have a red flag event. Basically, we had offshore flow, and it allowed for a little bit of drying and some warming across the North Bay, and that was about a week out before this firestorm actually occurred. The two graphs here are showing you the energy release component. An easy way to think of the energy release component is how much potential there is for fire. So if you want to think of it from a meteorological perspective, when we look at convection, we use CAPE. Well, from a fire standpoint, you could use ERC. These charts are showing you 90 to 97 percentile. And the last bullet there is your 10-hour fuel moisture. That's your finer fuels, your sticks and your twigs, and some of your grasses and brushes. Those were at record levels as well, sitting about 4 to 5%. So the stage was basically set from a standpoint from fuels to just go if a fire got started. We just needed the weather part. So here's the weather part. So meteorologically speaking, from pattern recognition, this was a classic setup for offshore flow, and this is where we get some of our strongest winds across the North Bay during the fall months. And we have strong high pressure across the Great Basin and the interior with lower pressure at the coast. These are two weather models here. The one on the left is the GFS showing you the winds at 850 millibars, and then the one on the right is showing you the NAM at 925 millibars, both highlighting very strong gusty winds of anywhere from 40 to almost 70 miles an hour across the North Bay. The white polygons that you see there are the fire perimeters. Obviously, they weren't there when the fire started, but I put them there as frame of reference. Another tool that we do utilize, we look at pressure gradients across California to rank kind of our offshore flow events. One that we use is San Francisco Airport to a station in Nevada called Winnemucca. Anything greater than about 10 millibars, 11 millibars is pretty decent. This one was being forecast to be over 20 millibars. So we knew from a meteorological setup that this was going to be very, very strong wind event across the North Bay, and it was forecasted several days in advance. As the two models show here, 72 and 69 hours out, the models were already hinting at very, very strong winds. Here's a weather model reanalysis. This was done by the San Jose State Fire Weather Lab of the WARF model. The top image is showing kind of a cross-section. So the two mountain ranges there, the one that we're focused in is actually the lower mountain range. That's the North Bay Hills. As the animation rolls through, you'll notice what appears to be a mountain wave kind of roll off there and down into the valley. That's actually what did happen. And on the bottom two graphics, you can see how we did have a mountain wave with Coffee Park. That's the picture that I showed at the beginning of the presentation. So the one on the left shows you the mountain wave servicing, and then the one on the right shows you the hydraulic jump that actually occurred after the mountain wave. So that shows the extreme nature of the setup here to produce very strong winds. So getting the word out. This was well forecasted way in advance. We issued red flag warnings here locally several days leading up to the event. We posted it on social media. We gave it to our partners in briefings. Our fire partners all knew that the stage was basically set from a fuel standpoint and a weather standpoint for potential from fire, extreme fire setup. So what actually occurred? Well, here's the offshore flow event for the October 8-9 time frame. This is on the pocket fire. This is the northernmost fire. We had a raw station, pretty historic raw station for our area, about 2,000 feet on a ridge line that measured a gust of 79 miles an hour. Should be noted that was also the strongest wind that raw station had ever recorded. We also had another smaller weather station up on top of a peak at Geyser Peak. That's about 3,500 feet. And it had a gust of 108 miles an hour when the fire actually was occurring. That wind speed might be augmented a little bit due to fire behavior as the fire was kind of racing up, but nonetheless it's emphasizing how strong the winds actually were. Here's another one. This is for the Tubbs fire. This is the fire that was the most devastating out of the three. Those are the photos that I showed earlier in the presentation. Here's the wind speed off of the Santa Rosa RAWs. We had a gust of 68 miles an hour. And I also circled the elevation, 599 feet. So not only did we have strong winds on our ridges and peaks, it actually made it down into the valleys and the lower elevations. And that's what the WARP model showed earlier on that animation, and some of the other models that we use also showed that the winds were going to be surfacing. And last but not least, here's the Nuns fire. This is another lower elevation at 411 feet. This one had a gust of 46 miles an hour. So each fire had some measurement of very, very strong winds. I wanted to include this slide. Even if we didn't have a fires actually occur, we still would have had devastating damage from a wind standpoint across the North Bay. This is a ranch that I went and visited and actually did a damage survey. I looked at it from like a tornado aspect. I used the damage indicators, and if you would rank it from a tornado, it had damage indicators equivalent to a low-end EF1 tornado. Large oaks were split in half. Those were healthy oaks, too. This is a well-maintained barn that the roof just basically got peeled back, and then they had a little calving barn there that got lifted off the foundation and blown down. So devastating wind damage would have happened regardless of the fires across the North Bay. So there again, just kind of emphasizing the extreme nature of this event. So moving on to the GO-16, now that we know that it was a strong offshore wind event, when did we actually first detect a fire? We actually run something here in-house. It was developed by another Sioux, and we just deployed it this year. It's a great tool for our office, and other offices do use it as well. So we were first alerted to a, quote, hit about 9:30 the night the fires broke out. And this animation here is showing you basically the fire temperatures from the GO-16. So when we get that hit, a script runs every 5 minutes and scans that GO-16 fire temperature, and if it sees anything greater than 600 Kelvin, that's a hit. And if it gets a hit, it pops up this red banner and alerts the forecaster on the operations floor that, hey, look, you might have a fire, you might want to do some more investigation and see what you can find out. This is a great SA tool for the forecasters. It can also provide lots of lead time on us issuing a spot weather forecast or doing a quick spin up to see what the weather is currently doing across that area. And if we do get a spot request from a partner, we're able to get it out the door even quicker. So the first detection came in around about 9:30 as the fires kind of were going on across the North Bay. Here's some GO-16 imagery. Going from the top left to the bottom right is about a 20-minute window, 9:27 p.m. to 9:42. The first detection there, you can see the 1 hour on the top left, and by the bottom right, we have 5. So in a matter of 20 minutes, 5 new fires, at least that what we could see off of the IR imagery, it started to crop up across the North Bay, and that's when we started to realize that this is going to be a rather big event, not just in the North Bay, but across Northern California as numerous fires started to take off. So this is an animation. 2 areas that I want you to focus on. One is down by Monterey Bay, and then the other one is over the North Bay. So as I click the animation to play, you'll first see that offshore flow kind of develops in the Monterey Bay area first, and that's our first indication of strong offshore. The low stratus erodes as the sun sets. Now focus your attention to across the North Bay, and you'll see the fires just take off. Look at the rapid rate of spread as it moves through. And sadly, knowing what we know now and seeing the pictures that I showed earlier, what was actually occurring on the ground when that was happening. But what I want to emphasize here is that rapid rate of spread, most of the fire growth actually occurred during that 6 to 8 hour span. So it just goes to show, the rapid rate of spread that we actually saw, and being able to utilize the animation from the Sims blog here is a great way to show that rapid rate of spread. And we were able to use this in the field also to kind of monitor how quick the fires were actually going. Here's another one showing you the fire temperature from the Sierra webpage slider. Once again, emphasizing how quick those fires kind of spread across the North Bay and across Northern California. Just emphasizing what an extreme event that occurred and how rapid those fires did move through those neighborhoods. And that kind of goes to show why we had some of the fatalities that we did. The fires just moved so quick that you just couldn't get out of the way. And unfortunately, Southern California is starting to see a very similar situation with the fires that are going on down there. They saw similar rates of spread. So when I'm deployed to wildfires, one way that we monitor our fire perimeters and fire growth is from IR imagery that we obtain from aviation assets. That could be helicopters, UAVs, or airplanes. Now this image here is actually a mock-up. It's not a real-world example. I'm just trying to emphasize or basically show how another way that I utilize GO-16 while deployed on wildfires. So this past summer, in addition to being on the North Bay fires, I was on several other fires, and we had numerous fires across the west. We also had aviation assets that were down for mechanical, so we couldn't rely on our typical methods to obtain our IR imagery. So I was able to supplement it by using some of our GO-16. So this mocked-up example that I have here, what I'm showing is a fire temperature. I drew in basically a fake fire perimeter, but by using the fire temperature, I could alert the fire personnel that the northernmost portion of the fire, or in this example, Division Bravo, you're starting to see the most active fire, or that's where we saw the most growth overnight. So it's a good way to supplement some of our typical IR imagery that we get on wildfires to help with mapping. Obviously, since we're so far west, we have to deal a little bit with parallax issues, so I could at least get them ballpark. I can't give exact details, but I correlate it with the radar imagery from smoke plumes to kind of fine-tune where that location is. But the point being is, when we don't have access to the IR imagery that we get from aviation, I can use GO-16 to kind of supplement it. It's a great tool, and the fire personnel greatly appreciated the information I was able to relay to them. This isn't GO-16, but I also wanted to show some great VIIRS imagery of the North Bay fires. This is also off of the Sims blog, flipping between the shortwave IR and the day-night band. They're again showing you how extreme this fire is and the massive amount of smoke that was happening during the nighttime. Here's another great VIIRS imagery. This is from William Straka, Wisconsin. Once again, showing you how much light was actually occurring from the Tubbs fire. And then you could also see the amount of smoke that was being pushed off. We use this locally. We ingest it in the AWIP, so we're able to pull it up on our AWIP system, but we also view it on the web. And it's another great tool that we use from a fire standpoint. I also wanted to show the satellite view here of the Landsat imagery, kind of showing you the Santa Rosa. You can see the Santa Rosa city proper there with the two burn scars, one to the north, and then that's the Tubbs fire, and then the Nuns fire is along the Sonoma-Napa County line with active burning. We were able to use this in the field, kind of highlighting where the most severe burning occurred. And then in the bottom right, we've got the Modus Terra false color imagery from October 25th. That's when most of the fires were done. Also kind of highlighting where the burn scar actually did occur. I thought those were rather interesting, so I wanted to share it. Okay, so some have asked, has this ever happened before? Well, sadly, the answer is yes. Are we repeating history? Yes. So if you look at the Tubbs fire, that's the black outline on this map. The red outline is the Hanley fire, and that occurred in September, also one of our fall months, 1964. 5,200 acres, 84 homes, 24 summer cabins. Obviously, it wasn't as populated back then, but it was still devastating impacts. From a weather standpoint, very similar weather setup. We did have a heat wave. Temperatures were over 100 degrees. Winds were on the extreme side. We had a lookout that was up on Mount St. Helena, which is up in the North Bay. 71 miles an hour with a gust of 122 is what they measured, and eventually the lookout blew down due to the strong winds. Numerous power lines were down, and in addition to the Hanley fire, 43 other fires did occur across the North Bay. So we did kind of repeat history, not necessarily a good thing, but it was something that was kind of eye-opening when you overlay the two fire perimeters. So a few takeaways on using GO-16. I think we're only starting to scratch the surface when it comes to the potential. We still have lots to learn. Sadly, we don't have access to GO-16 anymore. We're going to have to wait till GO-17 goes up in March before we'll have access to it. but I'm hoping it will be up and running by next summer, so we'll be able to use it on wildfires again. For me personally, this is the first full fire season utilizing Go16, so I'm still learning, as many of us are. One of the ways, as I mentioned, was supplementing it for the IR imagery. When we don't have access to it, it was a great tool to have in the field. We're basically blind, especially if there's an inversion and smoke is covering the fire. Not much you can see from your standard, satellite imagery, but having some of the higher res Go stuff was instrumental to giving intel to the fire personnel exactly where the fire was and what it was doing. So it was definitely a great tool to have. As I showed on some of the animations, it was a great way to highlight the fire intensity or the rapid rate of spread. Another tool there is it's more frequent updates than some of the MODIS or VIIRS imagery that we get. So there again, I could give more detailed information to the fire personnel, exactly what part of the fire was being most active. And last but not least, here we go, I forgot this one. So it could be the first detection alert to a fire. I showed how we use that locally. I know a lot of other offices use similar type of scripts or have stuff running in the background. And it's a great way to alert a forecaster that there actually could be a potential for a fire. And then last but not least, I wanted to give major kudos to the Sierra and the RAM slider web page. It's a huge asset to deployed IMETs. IMETs in the field do have access to a thin client or a downscale version of like an AWIP, but it can be very resource intense, and it's great to have another way to view Go16 in the field. So I just wanted to say a major thanks to RAM and Sierra for creating that web interface. But it was definitely a fire of my career. Hopefully I'll never see anything like it again, but being able to use Go16 to give the firefighters more detail was a huge asset. And that's it. Thank you.
Okay, any questions for Matt?
Hey Matt, this is Robin Heffernan. First off, thank you very much for your service during this event. Secondly, I have a couple of questions for you. First, with regard to the alerts that you're using, you've got your tool running there to alert the forecasters. What is your dissemination message in your office to contact emergency management, land management agencies, whomever it is you contact? How do you do that?
So we have not bridged that gap yet. Some other offices are utilizing what I think it was Norman, Oklahoma has set up. Ours is all internal. Ours is just a basic pop-up of the banner, and we're able to do some more investigation. It does not disseminate any product or email or text alert like some other WFOs are currently using. Ours is just primarily in-house.
And then you make a phone call if you feel it's a need to? Is that how you do it?
Yeah, we could call an EOC or we could call one of the dispatch centers to find out more intel if they've had any reports of fires.
Okay. And then my last question has to do with the parallax issue that you mentioned. How big of a deal did you find that to be, and on what products did you notice it to be the most significant?
So where I most noticed it is when I was looking at the fire temperature. It would plot it sometimes maybe a half a mile or 2 miles outside the fire line, and then it was a quick, oh my gosh, did the fire spread outside the fire line? And then, I'd match it up with a VIIRS or MODIS pass later in the day, and obviously it didn't, or we didn't hear radio chatter. So I most noticed it when I was utilizing the fire temperature and overlaying it with a fire perimeter. Sometimes those hits, quote hits, would come outside the fire line.
Interesting. I would think because of proximity to the surface with the fire temperature product, you wouldn't see it that much. That's very interesting to note. Thank you.
Hey, Matt, this is Joel and Juneau.
Hi, Joel.
Hey, partner, that alert you were talking about, is there any way that we could do that in the IMET laptops?
That's beyond me. I don't think so. Because those are all regional edict servers. You'd have to take it up with the folks in Boise, but I don't think so.
Okay, thank you.
Any more questions for Matt?
Yeah, this is Chris Schmidt out at Sims, a colleague of Scott Lindstrom's. You mentioned earlier that you have a fire temperature product you're looking at. which fire temperature product is that? Is that the official GOES 16 L2 fire temperature? Is that some other composite?
Which are you asking? The ones that are alerting us with the red banner, or some of the animations that I showed?
Not the animations, but like you said, the red banner, what kicked off the presentation when you showed those kind of pixels, and the one, and specifically wondering about the one that you said hopped around.
Yeah, I think that I'd have to look at the menu, but I think that one fell under one of the derived products showing up under the fire temperatures that show up there. I don't have that menu in front of me to look, but I'm pretty sure that's where I grabbed it from.
All right. Well, I actually have an explanation potentially for you then, since I'm the developer for that. The jumping around may have been navigation issues, because there has been a little bit of wiggle. Also, that product has some scaling issues that are getting fixed, so sometimes pixels will disappear when they shouldn't. So you're going to see some changes, and we'll have to make sure you guys get alerted to this in what appears, but it should look more stable in coming months, and you shouldn't have that kind of behavior.
Okay, well, thank you. That's a great product, and we use it a lot, and I used it when I was deployed on fires as well. So I definitely like it, so I'm glad to hear that it's going to be fine-tuned.
I was going to say, and this is Bernie from CIRA chiming in, which might be a little bit of why you were seeing some of the fires outside of the perimeter, and maybe that has to do with the satellite still jumping around in checkout period. So that might reduce some of those errors.
Okay, well, thanks.
And I'll add one more comment. This is Scott at Sims, and just because GOES 16 is going to be GOES East, that doesn't mean it will be useless for you. GOES 16 will still have better spatial resolution all the way to the Nevada border. And of course you'll have the better temporal resolution. So for a quick spreading fire, you'll have a very oblique look at it, but you'll still be getting imagery every 5 minutes, which beats GOES 15 hands down.
Yeah, I was actually on another call earlier that was discussing some of that and how we're still going to be able to use GOES 16 once it does come back online. We'll just be on the far edge of it.
Okay, any more comments or questions for Matt? Okay, we want to thank Matt for this great presentation, and a reminder that the next GOES 16 applications webinar will be on January 10th at 18Z, and it'll be led by Stan Zizik from the WFO in Las Vegas. Thanks, everybody, and have a great day.